go back to chapter 9. We had jumped over chapter 9, and this is on transformations, some symmetry in there. So today we are talking in general about transformations at the very beginning, but the focus today is on reflections. So talking about different transformations that we have, focusing just today on reflections. You don't need a ruler for all of it, but you'll see the part that you do need a ruler for. So a transformation, to start out, it is some operation that maps what's called a pre-image onto an image. So it maps a pre-image onto an image. A pre-image, this would be the original image, and then the image that it's describing, this is the new. So the pre-image is what you're starting with, and then after the transformation, the image is the new. It's been transformed. And there's 3 transformations. Reflections is one of them. Another is translations. Translations, so reflections, you're reflecting the figure over some sort of line of reflection, line of symmetry. A translation is you are actually moving a figure, so this would be where it moves either up or down, left or right. And then we have rotations also. So if you're rotating something 90 degrees or 180 degrees, rotating it about a specific point. So there are 3 problems below there. It says name each transformation that maps the lighter flag onto the darker shade. And for each of them, you can, maybe it's hard to tell up on my screen, but it is the top ones, that's the lighter flag, and then you can tell, hopefully by looking at your sheet, it's not a huge difference, but the other figure does look a little darker, more black than gray. So between those 3 transformations, what would you say is happening in number 1? How do you get from the lighter flag to the darker one? Translation, yes. What about the second one? You guys want to answer that one? That's a rotation, yep. And then last one is the reflection. So that's what we're focusing on today. So here, that line of reflection would be this horizontal line approximately. And we would say that lighter flag is the original image, so that's the pre-image. And the darker flag would be the image. Okay, so knowing that vocabulary, so if you're asked something about the pre-image versus the image, you know which figure to refer to. These are called rigid transformations. And what that means is the figure keeps its size and shape. So they keep their size and shape. There's another transformation, a dilation. It's not a rigid transformation. A dilation is when you are expanding or contracting a figure or an object, so that would not keep the same size for sure. Shape, yes, but size, no. And then these are called, so we have this word isometry, but they are also called, I'll put after this, it's a congruence transformation. Because the 2 images, the pre-image and the image, are the same size and shape, so they're congruent to each other. But then this is another term that means that, isometry. So now we'll get into reflections specifically. So reflections, this is the more mathematical term. You can think of these as flips, but to me that's a very general term for it. Reflection is how I phrase it. I'd like you to phrase it as a reflection and not say you're flipping an object, but you're reflecting it. These are transformed in a line of reflection. So reflections are transformed in a line of reflection, like I had drawn in on the reflection flag example where that line would be. So you're going to see when we actually work through these that you have the points that are the vertices of the pre-image, and then you have the points of the image. So the point before the reflection is the pre-image, and then the point after the reflection is the image. The pre-image and the image are the same distance from the line of reflection. So here's where, this is the only one on here that you really need the ruler for. You can use it on the examples on the back to help you if you want help drawing straight lines, but here's the only one you need it for. So you do have some problems like this on your assignment too, which you will have time to work on. So I'm going to tell you which ones those are so you can make sure to do those first while you have a ruler in case you don't have one to use outside of class. So when you have an object, so I have my 3 vertices of this triangle. And actually, I'm going to label these. Say this is A, B, C, triangle ABC. Then if I am drawing the reflection of that triangle, I want to make sure that like the reflection of point A is the same distance away from this line as A is. So I would measure that. I would measure, and it's up to you if you want to use the inches or centimeters side. But I would kind of measure how far my point A is from that line. And so it's about, I'm measuring in inches, so it's about 1 3/8 of an inch away from that line. So then I would want to go 1 3/8 of an inch on the other side and put a point to mark where the reflection of A should be. Should be about here. And I'm actually going to try to keep my ruler there so that my line ends up being straight. I would do the same thing for B, or I could just measure the distance from A to B to mark where the reflection of B should be. B is just a little over 1/4 of an inch away from that. And then you could, while your ruler is there too, kind of connect those points for that side of the reflected triangle. And then I would want to do the same thing for C. C is going to be the same distance that B was away from that line, but I want to line up kind of where it is. And then you draw your reflected image. So the ruler just helps you draw it more accurately, making sure, hopefully I didn't just get pen on my face, but making sure that you are the same distance away and that you have the straight edges and everything like that. Now I'm also going to show you how to label. When you label a reflection or at any transformation, when you label it, so the point that A reflects to is labeled as A prime. So it kind of looks like A and then like an apostrophe, or you could also think it kind of looks like A to the first power. But if you wanted to put after this, the way you say that is A prime. And so therefore the reflection of point B is B prime. The reflection of point C is C prime. So we will be labeling on the other side, and that's how they are labeled. So that way you can clearly tell ABC is the pre-image, and then A prime, B prime, C prime is the image. So you know which one is the reflection of which based on how they're labeled. Okay, any questions there? All right, then. So like I said, these ones on the back, you could use your rulers to help draw the straight edges, but you don't really need them to measure distances for these. So reflections on a coordinate grid. It says reflect the triangle in the given line. For examples 3, 4, and 5, example 6 is a quadrilateral. So we have triangle FGH, and we are reflecting it in the y-axis. So what I'm going to do, if you have a highlighter or even if you just wanted to mark it, because it might make it a little easier for you, I'm just going to highlight the y-axis. So I know this is the line that I'm reflecting over. Just makes it a little bit more clear. And then what I would like you to do is I'm actually going to label, I know these two triangles in examples 3 and 4 are the same, FGH. So I'm going to label the points F, G, and H, like what those ordered pairs are. Because then I would like you to label what the coordinates of F prime, G prime, and H prime are. It's something that later on you have to do anyway, and then it is asked, like on your quiz and your test, I'll ask you to name the points, so just doing that already is helpful because then you're used to doing it. So some of you I know might have started sketching already, but what is the ordered pair? What ordered pair is F at? Anybody? Ordered pair F. What are the coordinates? -3, 5. So you go left 3 and then up 5 to get to F. What about G? -1, 4, and then H. -2, -2. Okay, so now, because the line that we're reflecting over is a vertical line, you could just count the distance. Like from F to get to F prime, it's a distance of 3 from the y-axis, so I go 3 on the other side. And then I am going to label that point, that's F prime. And then G is 1 unit from the y-axis, so 1 unit on the other side. This is G prime. H is 2 units. So 2 units on the other side, that's H prime. And then, like I said, it's up to you if you want to use your rulers to help draw the straight edges, since you have the rulers. And if you're done and it doesn't, like you're looking at it and it doesn't look right, it doesn't look like that's what the triangle should look like when it's reflected over that line, just double checked. It's something not, like did you count something wrong? Something happened. But now I'm going to label what those ordered pairs actually are. What is F prime, G prime, and H prime? So what ordered pair is F prime at? 3, 5. G prime is at 1, 4. H prime, 2, -2. What do you notice when you reflect over the y-axis? What do you notice about the ordered pairs of the pre-image to the ordered pairs of the image? The x value changes how? Yep, it's the opposite. So all of our x values were negative. Now all of the x values are the exact opposite. They're positive. All of the y values are exactly the same. So there is a summary below. If you reflect over the x-axis, that is what, or I'm sorry, the y-axis, we were reflecting over the y, that is what you should see happen, is your x coordinate becomes the opposite. Your y coordinate stays the same. Okay, so that'll happen as a summary. In example 4, so here you're reflecting over the line x equals 1. So here I just want to ask you quickly, if you want to even make this note on your sheet. We have two types of lines if you just have x equals a number or y equals a number. So if you have x equals a number like x equals 1, is that a horizontal line or a vertical line? Okay, I heard both. I heard vertical and I heard horizontal. So here's the way to remember, other than having to memorize it. If I am going through, or if I have a line x equals 1, I should be going through the x value 1. So on the x-axis, here's the x value 1. I should be going through that, meaning I should be going up and down through it. So this is a vertical line. X equals a number are vertical lines. And then if you have y equals, those are horizontal lines because you have to cut through the y-axis, and that's horizontally. So here I would actually want to draw in the line x equals 1, so that's a vertical line. Or I would recommend drawing it in, and then I reflect over that. I'm not going to label F, G, and H again because it's the same as in example 3, but I am going to have you label F prime, G prime, H prime because they'll be different. So now F is 4 units away from that line. G is 2. And H is 3. Okay, and then if we have to label for this one, what are the coordinates of F prime? 5, 5. G prime? And H prime? 4, -2. So again, if you compare it to FGH, Y coordinates are still the same. X coordinates, you still have an opposite sign. They're not the exact opposite value though, because you're not reflecting over the Y axis specifically. So there isn't necessarily a pattern there. I guess if you look between these two, the X values all increased by 2 because you have an extra unit away from the axis. So an extra unit on both sides is an extra 2 units. Okay, then for example 5, so reflecting over y equals 2, is that a horizontal or vertical line? Horizontal. So y equals, it has to go through the y value 2, so it's this line here. And here I actually am going to have us label, I'll put those in a different color. I know some of you might be reflecting already, but can you just look quick? What is the coordinate of D? -2, 6, yes. And then E, -4, 3, and F is at 1, 4. And we're reflecting over y equals 2. So D is a distance of 1, 2, 3, 4 units from y equals 2. E is 1 unit away. F is 2. So if we label the image, what ordered pair is D prime at? -2, -2. E prime? -4, 1. And then F prime is at 1, 0. Okay, and again, because we didn't reflect over an axis specifically, you can see that all of the x values are the same because we reflected over a horizontal line. Y values are different. If you do, because I don't have an example of this, if you do reflect over the x-axis specifically though, you will see that your x values are the same and your y values are the exact opposite. So if it was over the x-axis, they'd be the exact opposite value. The last one on here then, example 6, you have to actually sketch the quadrilateral first. You're sketching both the quadrilateral and the, so the pre-image and the image. So if I graph quadrilateral ABCD first, I already have the points. So A is at 1, 1, and make sure you label them. So this is A. B is at 3, 2. C is at 4, -1. And D is at 2, -3. Okay, and then it says reflect in the line y equals x. So this line, the line y equals x, if you think of slope-intercept form, which actually that reminds me, the virtual lesson, the Desmos activity, you need to have done this week, and it's Friday already. So if you haven't done that yet, remember to check your email. Directions are in your email. You do have advisory today if you haven't done that yet. Otherwise, it's a 0 if you just don't do it. So make sure that you do that. This reminded me of it because it's on slope-intercept form. So slope-intercept form y equals mx plus b. If you just have the line y equals x, what is your slope m? 1. And then what is your y-intercept b? 0. So if you're graphing this line, you're starting at 0, 0, and then your slope is 1, so going up 1 over 1, up 1 over 1. So it ends up being the line that just goes through the bottom left and top right corners. That is the line y equals x. It's that diagonal line that kind of splits your graph in half here. Whoopsies, lost my ruler. Okay, so that's y equals x. Draw that in. Now, what happens when you reflect over that line is, it is explained below when you reflect over y equals x. So this is the line where all of the x and y coordinates of every point are the exact same. So any point on here, like you have 1, 1, 2, 2, 3, 3, -1, -1, -2, -2. The x and y coordinates are the same. If you reflect over it, that means your x and your y coordinates are switching. So it shows this down below. If you start with x, y, you are now reflecting it and the coordinates are y, x. So I'm going to list out, for this case, I actually list the ordered pairs. I'm going to list A prime, B prime, and so on before I plot them. So A prime, if A is 1, 1, A prime is still 1, 1. If I switch those around, I still have 1, 1, and that is actually on the line. That's why it's the same point. B prime, B was 3, 2, so now B prime is 2, 3. I just switch them. And now I can plot 2, 3, and that is B prime. And hopefully then when you see that, you think, okay, yeah, if I reflected B over that line, that makes sense, that's where it would be. And then C prime, if C is 4, negative 1, then C prime is negative 1, 4. Just switch the coordinates. So negative 1, 4 up here, that's C prime. And then D prime, D was 2, negative 3, so this will be negative 3, 2. And then you can draw in and you can label, I know I have it labeled A, you can label A prime next to it also, since they are the same point. But then if you kind of look at it or even tilt your graph, you can kind of see that, yeah, it is a reflection over that line. If it doesn't look like it, something might be wrong, so I would double check. So any questions at the moment on reflections?